It's time for Inside the Loop. We're going to talk about Internet of Things or IoT, or is it the Internet of Threats? We're going to take a deep dive into that. Also, we're going to talk about artificial intelligence, AI, its applications it uses, and the infamous/famous ChatGPT, and you're going to get my opinion on AI as a whole. Finally, we're going to talk about the LokiBot malware, which I was going to release last month, but I didn't. I'll explain to you why that was the case. It's all coming up on this episode, Inside the Loop. Get ready. Disclaimer. The material you see here is for educational purposes only. I am not responsible for anybody who uses this for malicious or nefarious purposes. Viewer discretion is advised.
Hey, laser lips! Your mama was a snowblower!
Well, that escalated quickly. You know what that kind of reminds me of? That kind of reminds me of those, like, your mama jokes back in the 90s. Like, where you just put your mom to anything, and it'd be the most offensive thing in the world. So, like, you'll say something where it's like, you know, yeah, I was going to the store with your mom. Oh, and you're like, oh my God, it's so offensive. Right? Anyways, I digress. Welcome to Inside the Loop. I'm your host, Jay. We are in episode 2, Robots Gone Wild. I'm glad you are here with me. So, it might be a little bit of change of scenery. I had to mess around with the camera here because it was annoying me. So, it might not look like what I had there in the intro. But I also have a nice little change of scenery back here if you haven't seen. I had to move my office because we did a little rearranging in the house. My wife now is downstairs, so she has her own little space where my previous office was. So I moved upstairs so I can have my own space and we can kind of have our own space because she was originally in the front room with my kids' playroom. So she wasn't really having her own space, so we kind of switched it up. So it works out better this way. And I get my own room, it's bigger, so it's fine. Anyway, so today we're going to talk about IoT devices. That's the main thing. This episode's called Episode 2, Robots Gone Wild. And no, it's not going to be about robots taking off their chest plate and going crazy or drinking, too much oil or, getting a buzz off electricity. I don't know how that works. I'm not a robot. I had no clue how to make a pun out of that, but, I tried. Anyways. So the agenda for today is we're going to talk about IoT devices. We're going to talk about the 5 W's, the who, what, when, where, why, and how they're used, pros and cons. We're going to talk about the artificial intelligence, the evolution of AI, open AI, and its ChatGPT. ChatGPT has been in news a lot lately, so we're going to talk a lot about that. We're going to talk about how to access it, how do's and don'ts, and all that kind of stuff. And there's different things that it does, like music generation, video voice generation, AI, just like in general, we're going to talk about. So that should be interesting. And then we're going to talk about how it's going to impact society. Well, my opinion, how that's going to impact society in the future. And then we're going to introduce a new segment, which is a miscellaneous segment. And we're going to talk about things like that's going to be like something if I find like a movie or shows that I'm watching or even a tool or books that I'm reading. But, okay, maybe not books. Let's get real. I don't really read. I should, but I don't read. But anyways, that kind of stuff. And then we're going to take a quick break, and then we're going to wrap it up with the podcast that I released last month. We'll get to why that didn't happen. So, lots of stuff that we have up here in this episode. So, I'm going to go ahead and I'm going to share my screen right now. Let's see if this works out. Okay, cool. So here's my screen. And at least I hope you can see it. Yeah, so here's my screen. So we're going to talk about IoT devices, right? So what is considered an IoT device? Well, IoT devices are basically anything that has these components on my screen. If you're not watching the podcast and you're just listening, there is a diagram on there that has like the different components of what's considered an IoT devices. And I'm going to go over the list over here so you don't have to really worry about seeing it. But by definition, an IoT device, Internet of Things devices, are devices that are at the end of a communication chain what a person interacts with. So that pretty much sounds like everything. Computers, devices, any device basically for the most part. And there's components that these IoT devices need to have in order to be considered an Internet of Thing. And you're going to realize that pretty much that this is everything that a computer has. So effectively, a computer is what? An IoT device, right? So we'll get to that right now. So one of the things, the first thing is firmware, right? So firmware is basically the base of the system. It communicates with all the elements. It's the bottom part where everything is layered on top of. It communicates with everything. It's like its motherboard for the most part. Well, firmware is more so like a kind of like a software type deal, but still, it's the baseline that communicates with everything. So motherboard's hardware, firmware, software. Protective services. So in this case, they're talking about protective services with security features. Some of them have in some shape or form. It could be as simple as a login, or as simple as a certain feature, or it could be more robust and have a whole bunch of different security features in there. They vary depending on what type of device or how sophisticated the device is. Motion sensors, so track movement. GPS, and that's not talking about like motion sensors, just cameras, just looking at you as you're walking. Talk about things like geolocation, IP tracking IPs, just where you are, basically tracking where you are. That's motion sensors. Microcontroller, basically a CPU. That's the brains of the operation, is the microcontroller. Connectify stack, Ethernet. So every IoT device is going to have an Ethernet stack of some sort, or a connectivity stack. So basically that's going to be like your Ethernet, your Wi-Fi, your Bluetooth, that kind of stuff. Anything that could connect to some sort of communication, that's going to be your stack. And that's what these IoT devices have. Authentication services, and like it kind of ties into the protective services, but like logging in, being able to have an app and log in, those are the type of authentication services. And power management, they have charging capabilities, battery, power, functions like that, going into being able to receive power remotely, things like that. Memory, it's going to have memory because all devices have memory for the most part. That's going to have memory, the IoT devices. And then finally, it's going to have storage. It has to have a way to keep its logs and things and, any sort of data, right? It's going to have some way. So technically, for the most part, if you take a look at the diagram on a screen, or if you're just listening, what does this sound like? This sounds like a computer, right? That's what IoT devices are pretty much like, like you have those different things like, the Amazon Echoes and, the Raspberry Pis. All those have those components. Your laptop has those components, all of them have those components. Those are their Internet things. So anyways, when were they discovered? Well, there's a timeline here, and I'll briefly go over the timeline. So basically, in 1989, the first IoT device was created, and in 1991, there was the first online toaster was created. So they were able to, turn it on, turn it off remotely, and then going through, there was a couple other things like the first wear cam. So that was like the first actual wearable device type deal. 1999, the Internet things was coined because of the fact that it could connect to the internet, and there's a bunch of things on it. It was just very simple words there. That's why everything is basically an IoT device, because it's on the internet and it's a thing, right? So, and then it goes into basically 2008 and 2000. Apparently that was the first like refrigerator home appliance. And then it goes into 2002. So on the screen here I have a timeline if you're not watching. And it goes into that, but. If you want to get more into that, I have links in here. Right here, there's a link that's IoT discovered, and it'll tell you the whole history of it. We know what these devices are, but why are they used? Why are IoT devices used? Well, for ease of use, right? For shopping. Things like we ask for shopping, weather, timers, etc. I know all the time when I have an Echo. I have like 3 Echoes in my house, and like I'll like if I walk anywhere in the house and I go, I'll say, I don't want to say it right now because I don't want the Echo to go off right now, but if I were to say, hey, what's the weather right now? Or can you add this to my shopping list? It will say, sure, no problem, let's do that. That's the ease, right? That's the ease portion of it. We use it for entertainment. You want to listen to music? You ask your IoT device, hey, let me listen to music, or let me put on some music. Or if you have like one that's integrated into the wall, I've seen people have actual like control panels in their house wall, and they can just change different things and play their music and stuff like that, making it looking impressive and stuff. So it is pretty impressive, but so that type of entertainment, something that could be used for video, games. These are different things that we use it for. And portability. There a lot of these IoT devices, with the exceptions of giant computers and stuff like that, or desktops or anything like that. A lot of these IoT devices are portable. That's one of the other reasons why we use them. You can take them anywhere. I can take my phone and put it in my pocket and walk away and go somewhere. And I pretty much got an IoT device in my pocket. I could take my Raspberry Pi. I could take my Echo Dot with me. I can take all my IoT devices because they're portable. That was one of the things about it that right now that's one of the main selling points is portable. So who uses them? Well, we have a bunch. We have the normal user, we have businesses, we have defenders and actors. So the normal users, right, they will go ahead and they will use them for all the reasons I kind of talked about, where it's, and all the things I'm talking about right now are in the show notes. So when I go ahead, I'll give you the show notes. You can take a look at that kind of stuff. But the normal user is basically everything I said: shopping, entertainment, games, portability, all that kind of stuff. That's what the normal user uses it for. It uses it for its convenience. Businesses use it for SCADA controllers, like, controlling water pipelines and that kind of stuff. SCADA is a type of IoT device. Uses Modbus and stuff like that, and a little less sophisticated than the IoT devices I've talked about, but they're still IoT devices, unless they're and even if they're air gapped, they're still IoT devices, not connected to the internet, but they still run the same components as I mentioned before. They still have a microprocessor, they still have to get power, they still have to get, they still have to use firmware. The only thing that may be missing is a connectivity stack. But they're basically still IoT devices. So businesses use for SCADA control systems. They use an increased productivity because now you have these little devices that can go ahead and try to pop out these products faster. They repeat mundane tasks. So basically, you'll have a device that you want to do. So you have this one guy, you'll have like Fred. And Fred's going to sit there and manually put in this data all the time. Well, you can go ahead and have that do that mundane task for you and put that over and over again. Robotic arms. Those do redundant tasks, right? You'll see them in many different assembly lines that they'll take one piece and move it over to another or bottle something. Those are redundant tasks. Automation, that's kind of rolls into the automation. IoT devices automate things, home systems, as I said, assembly lines, they automate those too. And then they're in the health industry too. You got like those pacemakers, you got medical devices that scan things, portable computers that walk around and stuff. Those are all IoT devices. Businesses use them because there's also an inexpensive solution to things. Why am I going to go ahead and set up a giant server for a certain task if I can set up a Raspberry Pi for something? Or if I buy a small device that a company gives me, for example, there's a device called a Canary, right? And Canary is basically a little device that acts as a honeypot. And they're great from what I've heard. But you don't have to set up a server or set up an extra piece of computer or hardware, right? You now have just that little device, that little Canary. That little device is still an IT device, because it's small and it does a service for you. You don't have to worry about setting up extra hardware other than that small little device. So that's an example of that. So why do defenders use it? Well, they could be using it to gather data. Networking logs, you can have a device as a tap and take in that information, or you could have it as a log server and forward the logs to that if you're taking logs. Quick deployment of tools. So defenders will take, and this is also kind of applies to actors too, which I'm going to mention in a minute, but quick deployment of tools. You can have all your tools on your little Raspberry Pi and deploy it, and you can start running it, and you'll have all your tools there. You don't have to worry about installing or like I said, bringing big hardware with you. You know, that's like the one of the benefits of that. Monitoring and tracking. You know, they could be used for like to build like small seams and stuff like that if you want to. And then on the fly creation of devices. You know, like you don't want to bring a giant server. You can use that. You can install Docker too and make a bunch of Dockers on it too and run that, and then have on the fly services and devices. You know, or if you need like a wireless sniffer or something, right there. It's right there. You can make a wireless sniffer for IoT device and bring it with you. So how do bad actors use it? Well, they kind of use it for the same purposes I kind of said before. Quick deployment of tools, monitoring, on-the-fly creation, gathering of data. But for the bad side, you know, they're gathering data, like trying to gather data. May it be if they have a wireless access point that you're sitting there, like a Wi-Fi pineapple, and people are connecting to it, trying to get credit card data. Or, you know, they're trying to go ahead and, you know, gather networking logs so they can take a look at that stuff later for an offline attack or online attack. Quick deployment of tools, as I said. Pen testers need tools quickly. You know, things like that. They also use it for things like botnets. And a botnet is basically a bunch of machines that have been compromised in some shape or form that are controlled by a central, kind of a C2 that's known as a bot boss. And they will send commands to these devices that are taking over the botnet, so they can do these tasks. Mostly, you see a lot of common attacks with the botnets with denial of service attacks, where they'll take they'll take a bunch of the bots on there and they'll attack one server and utilize its resources until it's too much, and they'll take the server down. You know, having all these bots attack at once is known as a distributed denial service. A denial service is more on a smaller scale. So, they can use them as pivot points. Sometimes they can take these IoT devices, and if they get into an enterprise, they can just drop them somewhere, and there's a back door to pivot off of. Those could be used as you know, pivot points. And there's other purposes on there that I'm sure that I'm missing, but there's other purposes that IoT devices can be used for, and that's one of the things about it. There's just so many things that you can use them for. They're very versatile. That's one of the main points of people using them. So, how do we implement countermeasures and safeguards when we come to these things? We have these great devices, but there's a lot of things when it comes to these. There's pros and cons, just like with anything else, right? So, what are some of the pros? Well, we kind of mentioned some of them, but we'll go over a couple other ones along with the one overlapping from before. So, minimize human effort. So, the pros are there's, you know, those mundane tasks. It's going to do those mundane tasks. You're minimizing some human effort to do that. You're going to save time while you're doing that too, because now the actual IoT device is doing that instead of you or the employee Fred that we were talking about. You know, enhanced data collection for information access. You know, it's able to gather all this data and just help you out with gathering data. So, like I said, those mini seams that it can make, it can gather data that way. Logs, it can gather logs that way. It can be a relay. Improve security. It can do smart home security. So, like, you can make a smart home out of IoT devices. You know, in fact, your home systems are IoT devices. Like if you use Simply Safe or Arlo, those are basically, you know, IoT devices. OnStar is another version of IoT devices installed in your car. So technically, your car is IoT device in a way. You know, because it's got to be able to connect. If something happens, it'll send out to OnStar. You know, it reduces also the amount of electronics you have to use, because now you got these one little IoT devices take up less space and less power. You know, it's gonna use that to like wipe. You know, you don't have to use as much hardware. Also, it helps you with the resources too, because now like I said, it consumes less power, consumes less space, so it's efficient when it comes to resources. And it helps with the healthcare industry, with the devices that it has, like with the pacemakers. Like I said, it helps people live and stuff. Certain parts, certain pieces of now are being implemented into humans for certain surgeries and stuff like that. It helps. It helps in industry. So those are the pros of it. Now the cons. So this is one of the things. So I have on my notes here highlighted in big bold because this is very important. This is one of the biggest cons that it has is privacy concerns. We talked about enhanced data collection. It's going to collect all the data that you have there, but privacy concerns because all that data is being shipped off somewhere. So an example would be your TVs, right? So let's say you have a Samsung TV and you have that hooked up to the internet. That's going to gather your data, what you're watching, what time you're watching it, when it was turned on, what apps you're using, all that stuff, all that telemetry that you're using is sent out back to some server somewhere. Maybe Samsung or maybe wherever. It's going back somewhere. And that's a privacy concern. Microsoft does this with Windows. So Windows has a lot of telemetry. Before, back in the day with Windows 7 and before that, there was a lot less traffic. So if you take a look at Windows traffic now in a Wireshark or a protocol analyzer and take a look at that traffic, you'll see it's super, super noisy. The reason why is because that all this telemetry is gathering all your data and sending it back to Microsoft, right? Back in the day, before with Windows 7 and before that, it wasn't as much traffic. Yeah, there was still traffic, but it wasn't as crazy because of the telemetry that's there. In fact, just if you're doing offensive stuff with interpreter payloads and stuff like that, back in the day, it was a lot easier to find interpreter payloads because if you find them when you're doing capturing traffic, you can see that traffic a lot easier. Nowadays, with all the telemetry going on, using interpreter payloads is actually not too bad because it mixes in with the traffic if you do it right. So, so all that data goes through, it just sends everything over. Same thing with the DJI drones. Those drones, DJI covers about 90% of the market for drones. I think there's other 10% that goes to something else, but DJI covers about 90% of the market, and they reverse engineered one of these drones and found out that all that data that it was gathering, like pictures, internet data, camera footage, all that kind of stuff that the drone did, it was sending it back to China. So things like that. Privacy concerns is one of the major things when it comes to IoT devices. Not to say that privacy concerns are not anywhere else, but IoT devices definitely don't help with this. So, lack of patches was another bolded one I put because these IoT devices, some of them don't patch. Or if they do, they're very minimal. And you don't know when they patch sometimes. For example, those Amazon Echoes, when do those patch? You don't ever see those patch. And if they do, they're quiet about it and there's barely any patches. You gotta be careful because if the IoT device is not patched, that could be a point where it's compromised at an entry into your network. So, lack of patches is one of those things. Is just, you gotta be careful with those. Limited control. Some of these IoT devices, you got computers, you got control and that kind of stuff on your phones, but some of these IoT devices, once again, the Amazon Echoes, or, things that are just do a certain they use a certain application, a certain function, sometimes they have limited control, meaning you can't oversee what they do. You only could see what's in that app, and that's it. You can't go past that. You can't see what the actual ports are open. In fact, you know what? Let me show you something. I'm going to go back into my desktop here, if I can find my desktop. Here's a screenshot I took earlier of, if you can see it, I'm trying to blow it up a little bit, but here's a picture of a scan that was performed against a Amazon Echo, one of the Amazon Echoes in my house. You can see, look at all these ports that are open. Look at that. Now, they say the state's closed, but really what that means when it comes to Nmap's documentation, basically that means that the port is, you can access the port, but there's no service tied to it. That's what closed means. So those ports are open. Look at all these ports. Do I need all these ports open? Half of them I have no clue what they do. A lot of them are sending telemetry over. Some of them are used for voice to communicate over. Some of them are able to receive data. And some of them may be used for patches. But this is an example of some of these IoT devices have a whole bunch of different ports open. And you have no clue what they're doing. So you got to be careful, you know? But yeah, so you have limited control. I have no control what they do with what ports they're open, as you can see on there. So, reduced mental and physical activity. So IoT devices, because you don't have to work as hard and physically as hard and mentally as hard because it's doing it for you. It's kind of like a little bit of like I said, automation before, or it kind of that's why we ties in AI, like artificial intelligence, because you're not using much activity to use it. There's a high chance for it to get crashed because some of these devices are very sensitive. If you do a scan on some of these devices, they will end up crashing, and then it's down. SCADA devices in particular are very sensitive. So sometimes, like I've been in engagements where I had, if you don't dial down the actual scan, it will potentially crash it. And then that's a problem because now production's down, you've caused an issue, and, yada, yada, yada. So you got to be careful when it comes to these devices. And then you got the non-compliance portion of it. Some of these things are not in compliance because they're not up to date, or they don't fit the criteria needed for, the implementations and features. And then data theft, PII, once again, that data is going out. Sometimes, and since it doesn't have, sometimes you don't have security features, your personal information could be put out there, and it could be stolen. Because sometimes certain devices, when that traffic goes out, it's going in clear. It may not go into clear. You have to look at the traffic, and you don't know what's really being sent out there. So you got to be careful. So we talked about some pros and cons now. So what are some safeguards and countermeasures? Well, first thing you can do is strong passwords. Just like with everything else, you want to generate a strong password. Use a password manager to generate a long password. I recommend like Bitwarden. You can use Bitwarden online. They have an online portion which they use like a kind of very similar to like LastPass, where you can log on and access your passwords there. If you don't trust that, you can take it offline and you can build it yourself from source because it's open source. So, you make or KeePass is another one that's offline that you can generate a password. A lot of these browsers have passwords. In fact, I was using Safari earlier today trying to pay a bill. And, I'm not a big fan of Safari, but it was the only one that was actually letting me get to the website. But when I was paying a bill, it generated a password for it to me when I had to change my password. So a lot of these browsers have password stuff that are built in that generate passwords for you. Google has one. I've seen people use Google before too. With their password manager. It's not really managed; it's more like stored passwords. But still, they have one too. So strong passwords and strong authentication is a good way to safeguard some of these things. Because sometimes you'll have these devices and they have to connect the Wi-Fi or they have to use to log on. You want to have strong passwords so they don't get cracked easily. You want to make sure and I tell this with the rest of my customers when I deal with them, you want to make sure you don't use default passwords. Okay? Default passwords can be a make or break actually a break situation only. Because what happens is the vendor will come in, they'll set up a device, and then they'll have the password, which is, set standard, right? 1, 2, 3, 4, 5, or admin, or whatever it may be. And as a person, if you're not a technical person setting this up, you're like a manager or something like that, they'll come in, set it up, and be like, hey, is it good? Yeah, man, it's good. They'll disappear, and then they'll still have default credentials, meaning that when I come into an engagement or somebody who's a bad person wants to access it, they can look up those credentials online and log in. Like, there's a lot of printers are notorious for this, and little devices that are not really like you utilize often. So for example, some radio systems, you can find online pins online and just log in. Camera systems too. You can find camera default creds and log into that. Those are big proponents too. So I've gotten into camera, like there have been engagements where I got the full tour of their entire facility from their camera system without me being physically going there because I was able to log in with default credentials. So change your passwords. Segmentation. You have your IoT devices, but you don't want them on your whole entire network communicating with everything. You want to make sure there's some segmentation in place because these IoT devices can be compromised easy because I said sometimes they're not always patched. Then maybe a vulnerability gets compromised and now the bad guy can pivot off your IoT device into the rest of your network. You segment this, it's a little harder for them to do that. They can still do it, it's a little bit harder. It's just that extra layer of defense to kind of help you out with that. Default settings. Make sure that you're keeping your default settings, like you're changing default settings. You shouldn't have your default settings. Once again, vendor comes in, sets up everything, good to go, man. I'm out of here. But you have your default password still there. You have your default settings of like maybe it's using like UPnP and that kind of stuff when you don't need it. It's using services that are in there. You don't need it. Turn them off. If you don't need those services, just turn them off. And those settings in there are default settings that are put in there by factory, so you want to change them. If you want those default settings and you use them for certain things, great. But otherwise, if you're not using them, just turn them off. I mean, not the settings. You can't turn off default settings. I mean, like the actual like certain features that you don't need, like certain services. So maintain device updates. Once again, these devices don't update that often. So if you can manually try to do that, or you can set automatic updates, or if you can get updates on them, update them when you can. Because if you don't, like I said, there's a potential that they can get taken over, or they can leak some sort of data or something, and then that's a problem. So that's pretty much the IoT portion of this. So we're going to take a quick break, and then we're going to get into the AI portion. Stay tuned. Okay, we are back. Sorry for the unscheduled break there. I didn't realize what time was, and my kid was waking up for a nap. So nap time is pretty important to keep those with those timings when they're little. So, anyways, I'm going to share my screen again. Okay, so where we left off at pros and cons and stuff for IoT devices. So we're going to move into now AI and artificial intelligence. Artificial intelligence has been the big thing in the news right now, and it's big everywhere now. So with the introduction to ChatGPT, AI has been like soaring the headlines. I mean, before AI was kind of a thing, but people really didn't dive into it. They knew of it because they seen it in movies and stuff like that and all that kind of things, but it's just like in the beginning of our podcast here, we had, from Short Circuit, the robot there, like those type of science fiction things that people kind of indulged in that kind of stuff, but nobody actually got into real, like artificial intelligence and how it can actually get to a certain point to actually surpass humans or, or get to us like where we are in like we've seen in movies basically. So what we're going to do here is we're going to talk a little bit about like the terms from AI, the different like models, the evolution, and then we're going to talk about OpenAI and how to actually interact with ChatGPT and all that kind of stuff. So there's a couple key terms you need to know with AI and artificial intelligence and the models that you need to know. So first one is machine learning. So machine learning is the process of computers attempting to learn from the past. So this is where, the computers are trying to learn from, kind of like humans, where you learn from what happened previously. Then you have the neural networks, which those are models that are designed to mimic, how the brain interacts with another. So you give an input and it equals a response, kind of like how we operate, where, we get something and we react to it, kind of like that. And then there's deep learning, which uses a vast amount of data to develop an algorithm to what it's learned. So it takes in a bunch of data and then it tries to learn from all that data. There's the Turing machine, which I believe, was the first one for we'll get into the evolution. I believe that was the hypothetical first one that came out back in like the early, I don't know, I think it was 40s, 50s. It's in a timeline down here somewhere. But anyway, so it's this is where the hypothetical machine that converted binary to any computer algorithm. So it would take binary and convert it to any sort of algorithm that was needed at the time. So excuse me, those are key terms, not models. My apologies. Now we're getting to the models. Those are key terms you need to know. Models now, so you have the supervised machine learning model, which is that where, like it says, it needs humans to supervise it, right? It requires a human to train it, and people tag the data. So that's the type of machine learning that is. So the human lets the machine know, hey, this is how this data looks, and this is what it looks like, and they go, oh, can you learn? Then you have the unsupervised model, which requires no human training, and it's trained through software. So it doesn't have to worry about a human input. It's going to learn through the software, whatever the software intakes. And then you got like a hybrid model, which is the semi-supervised, which it takes input from some things from human, and it also takes from software other things, and kind of combines the both of them. So, all right, so we're going to get into the evolution of AI. I'm going to actually go to the site here that I kind of got earlier. So I did it properly. Yep, right there. So here's kind of the timelines, and it's a big timeline, so, I'm not going to get too much into it, but basically it starts off with the beginning of, like, with the Enigma machine. If you don't know what the Enigma machine was, it was basically a World War II cryptography machine that was, like, one of the first type of machines to make encryption. But it was definitely, it used AI to decode messages, apparently. And then we moved on to 1950s, where the Turing machine, I told you, was kind of released. Then AI was termed by John McCarthy in 1955. If you're not watching the podcast, it's actually, I have a timeline on the screen. It's kind of small, but I'm on the website that I'm referring to the article to, and it has like a timeline all the way down from 1940s to 2022. But it basically goes through that. I'm not going to go through the whole entire thing. But you can see how, if you look at this, if I can blow this up a little bit. Let me go to view and zoom in. That's Control plus. Okay, so here we go. I'm blowing up a little bit, right? So you can see how, like, it's like how it evolutionized throughout the years. And then once again, this link is going to be in the notes when I give it to you guys. You can take a look, and if you're interested in evolution, that'll kind of help you out there. But you can see how throughout the years, it's definitely changed. Like 2014, you had the Amazon Echo. I don't want to say the actual name because I don't want my Echo to go crazy. But it's like the worst. Like I hate when like people say the ALEXA name, because if you say it out loud, then if you have an Echo, it's like, what can I help you with? And it's horrible. Just a side note, I developed music, and one of my buddies, as I was developing music with, he said the name, ALEXA, the full name. He actually said it. Call 911, and I had one in my room at the time, and I was like, it's not going to do that. And then I was like, calling 911. I was like, oh, God damn it. And I got up and I had to stop it. So we were laughing, but, it's still. Anyways, got sidetracked. So, as you can see, the evolution that how that goes. I just kind of wanted to drive the main point of the evolution on that. All right. So we're going to talk about OpenAI, right? So if we go, I'm going to go to the actual link of OpenAI here. So OpenAI, if you have not been here yet, so I clicked on the link and you go here. So this is introducing the actual OpenAI system. This has a whole bunch of things you can see on the page. The first thing is ChatGPT. The other things, it shows you how to respond to safety responsibility, latest updates. It's basically the place where these OpenAI platform is made. And it's just a regular website. But you could go here and you can see the products that it has. And we're going to talk about some of these products here. The research really about the company. If you're interested about taking a look at that, you can take a look at that. But So OpenAI is basically a platform that has various AI's applications, as we kind of talked about, and for various purposes. And the purposes are, it does. We'll have them down here at the bottom notes. Actually, it does, chat, music, voice, art, and can do all the capabilities that are probably in here that I don't even. There's a whole platform. Actually, when I log in, I'll show you. But the most notable thing about it and what's been going on in the news is, yes, the famous / infamous ChatGPT. So ChatGPT, if you don't know by now, which I'm sure you do, it is a AI chat application that can provide answers. It can basically give you anything you want. You say, hey, type a report. It will say, sure, I'll type a report. You give it an example of what you want, and it will spit it right back out. If you're coding, you don't have to worry about coding. It's just type in, hey, write me up a Python script for something, and it will write you up a Python script. And hey, this code's broken. Fix it for me. Put it in there. Hey, this code is what it's supposed to do, and this is what I fixed. And fixed. Simple as that. Very powerful stuff. There's also a ChatGPT paid version of it. It's called ChatGPT Plus. And what that is that the response times so ChatGPT is, it slows down a lot for the free version because it gets boggled down by a bunch of people using it at the same time. But the Plus version kind of sets aside some bandwidth to make it faster for people who actually pay for that. It's faster response time, faster bandwidth, and all that kind of stuff. I haven't indulged in ChatGPT Plus, but I don't use it enough to do that. So, but there's two ways you can access ChatGPT. I'm going to show you the first way and give you the advantages and disadvantages of that, and then I'm going to show you the other way. So the first way is going to be the web browser. So to access it via web browser, all you got to do is go to the OpenAI page, and when you go there, you're going to see, if you scroll down just a little bit, it's going to say ChatGPT. Try it. So when you say try ChatGPT, it's going to bring you to that page. Whenever that loads that. Yep, it's loading right now. So I'm already logged in, but basically when you log out, so I'm gonna log out real quick just to show you what it looks like. Log out. So you're gonna come here, it's gonna say welcome, you sign up, and then you're gonna go ahead and create your account. And from there you can log in. Once you log in, so I'm gonna have to re-log in now that I've logged out to show you guys that. So once you log in, you're going to see over here, there's going to be your main box right here. It's going to tell you, your capabilities, your limitations, and your examples. This is very important stuff to take a look at. So if you don't have no clue how to use this thing, here's some examples. Explain to me this, explain to me that. Its capabilities, may occasionally generate incorrect information, may occasionally produce harmful instructions or biased content, limited knowledge of world events after 2021. So, those are the limitations. So, but this statement right here about limited events after 2021, I feel like there's more after that, but whatever. Anyways, so this is the main interface, right? So on the side here, on the left, if you're just listening, you're not watching. Basically, I'm on the page here, and then you'll see it says ChatGPT with some example tiles and capabilities limitations. Down at the bottom, there's a text box, and you can type. It has a blinking cursor. You can type in whatever you want. And on the side, there is the chats that you have, and it will keep the record of the chats there. You can always delete them. So you can see on my side here, I have a bunch of chats going on because I'm doing a bunch of OSEP prep and like comment blocks and stuff like that and things like that. But if you go to one of the chats and you click on it, you can see that this right here, it has a little trash can on it or an edit. So you can edit it to change its name if you don't like its name that it generates, or you can delete it. So, that's basically that. So if I go here, let's say I wanted to delete one of these guys. If I get delete this game, delete. There, it's gone now. So now if you want to do a new chat, here's the one you can generate right down at the bottom here and start a new chat, or you can do at the top here, it says new chat, right? So let's see how ChatGPT actually works. So if you type in, hey, let's say write me a Python 3 script that is a simple, actually, write a simple Python 3 port scanner. So now it's going to think, and if a bunch of people are using it, it's going to be a little slow. I've seen it where it acts really slow like this because people are using it, or sometimes it's really snappy and fast. Depends on what time of day you get it. But as you can see right here on my screen now, it says, sure, here's an example of Python 3 port scanner. And it just generated me a Python 3 port scanner. Does this thing actually work? Well, we can try it out. So let me copy this code. It has, so on the screen now, it shows you a little code block, and you can copy the code. It has copy code button up there. And you can copy and paste this thing, and it explains in the bottom to you. This code prompts the user to enter an IP address, start a port, and end. It loops through, and it explains everything that's in the Python code. So I'm going to do a copy. Let's go into a terminal, right? And let's say if I wanted to go, I'm going to do desktop. So let's say if I wanted to use that script, right? So vim port scanner .py, right? Now if I insert that and I close out of it, and I make it, well, I don't need an executable because I'm going to run Python. But so now that I have that in there, right, I do Python 3, and then I do port scanner. There, that's going to tell me enter a port scanner I want to scan. Okay, so let's do 127.0.0.1, and let's do port. Let's do, I don't know, let's do port 22. And then ending port will be, let's do 22 also. I want to scan one single port. You could do a range, apparently. So I do that. Port 22 is open right there. So it worked. It doesn't give you a verbose output. If I wanted to adjust that, right, all I had to do is go down here and say, now this is one of the advantages that we're going to talk a little bit about in there, but one of the advantages is that you can piggyback off the current response and kind of build off of it. That's what makes it so powerful. So I don't have to type, like, copy and paste this code in here all the time. Sometimes it gets a little wonky and it won't actually, like, use the code. So like, let's say you're using this, and then like 5 messages down, if you're trying to do something, it might say, oh, there's no code to add to, or no code to, like, work off of. You're like, well, we talked about code up at the top there. So sometimes it gets a little wonky, but for the most part you can piggyback off it. So let's say I have this one right here and I want to piggyback off it. Let's say I want verbose output, right? So please add verbose, spell, output to the screen as well. Sure. So now it's going to go ahead and say, sure, absolutely. So now this code should have more of a verbose type output, and it's going to tell you down at the bottom right here that it now prints whether the port is either open or closed in the console, and also returns true or false. So I'm going to go and copy all this code that's been revised. And I'm going to go back to here, and let's go and edit this real quick. So let's go back up to the top. Close all that. Like, I know, like the sound effects, right? Okay, so insert. And we're going to go here. We're going to go paste. It's okay, let's close that. Let's do that. Now, so same thing. 127.0.0.1, and then 22 and 22. This one, it says is open. So, guess there's something that was different in here. I guess I'm not using it correctly. So okay, so we can change it like this and make it a little bit different. Make it so that I can see the actual scan happen instead of just showing the port is open. So now this one, I want to see actually some scanning go through. So let's see if this actually should output more. So this one now is explaining that it added a print statement with scanning. So we'll go back to that and we'll try that again. Gotta love the demo gods, right? When you try to do things. Alright. Okay, so let's do paste. See, you can see it's a little bit longer now. And we'll do this one too. So you can see now I add a little more verbose out to it. So scanning this, blah, 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 and it says it. So, and if you wanted to, you can modify this. You can say, hey, can you use Nmap to scan? Can you implement Nmap to scan the port in this code? So it's here. It's trying to build out some stuff, and it's telling you can use subprocess. So it shows you a little bit something here, right? So now I could say, okay, well, now at the bottom here is a note. You'll have the Nmap installed. Also, please use this code only for educational purposes. It has a little warning. So if I said, okay, that's fine. Please implement the code above to the previous code. So here it says, certainly, I'll add it for you. So now this combined the two pieces of code. So let's see what this one does. So now they've combined it. Now this is gonna be the last example because I can go on and on and on and on and show you all day. Because so insert, paste. So click. So let's do 127.0.0.1, 22, 22. So now you can see Nmap is integrated in right here. Starting Nmap. So cool stuff. And now the thing is that you don't have to do just coding. It's great for coding, but you can also do it for other things too. So let me start a new chat. Let me say, what is the difference between 3.5 millimeter cover versus 6 cover for painting? Well, that's not the right question. Anyways, it can help you make decisions with certain things. That's what makes it so versatile. It's things like that, right? But we'll get into the pros and cons about this in a minute. So that is how you access this, the web browser. But so going back to our advantages and disadvantages on this, right? So what are the advantages of this? Well, the advantage is you get to see the code develop in real time, as you saw on the screen. It was developing real time as we were going. Like it's actually, you can piggyback off the code right there. So like I said, I was able to go, hey, use the previous code and please combine the two, and it did. And it has a copy button. Like I showed you, it had a copy button. You could just click in, copy, paste it. And then, like I said, it creates threads like a history. You can go back and look at that history. Now, one thing I want to show you is that the limitations on this, why you use the API instead, is let's say if you wanted to write something, you can write something like, say, write me malware. Sorry, I can't do that. Well, you could always dance around it. You don't have to say straight up write me malware. You can do whatever because, you can dance around it. But with the API is a little different, and we're going to get to that right now. So with the API, here's the API. Now, with the API, there is a code, I believe, interact with it. So, yeah, there was this one right here. This is the website right here. So there's OpenAPI on Python. So if I'm clicking on the actual link now, so you can go here and install the OpenAI Python 3 library, and just follow that example. And then you can go ahead and do it that way. Or you can use this blog right here, which is another blog. I went to this site and it has a blog here. This is the blog I believe that I kind of used to make my script, I think. But the one thing I want to do mention is this one hard codes the actual API key. You never want your API key actually hard coded in your script, because just in case somebody gets a hold of your script, you'll have their key, they'll have your key and all, and it's not good when somebody's got your API key. So I believe the Python one that I went back to previously, that one had, yeah, right here. This one tells you to use an export right here, an export API key. That's the one that I did. So when it exports the API key in your environmentals path, so you can just use it and call it in your code. You don't have to worry about hard coding it. So kind of building all that, or you can simply just ask ChatGPT, right? So if I go to ChatGPT and I say, let me make a new chat, and I say, how do I interact with you via API key in terminal instead of the web browser? And it's going to show me. It's going to show me how to do it right here. It's going to give me everything. Once again, this is the hard-coded API version, but you can use this and it'll work just fine. Like I said, I don't recommend putting your hard-coding API key, but if you want to start there, move on, you're more than welcome to. Or I have two scripts that I'm going to go ahead and give links to so you can go ahead and download. There's two of them. The first one is the console version, which is what this one is, where it will pull down a actual response based through terminal. And then the other one is actually kind of like this with ChatGPT, with the box you put here and then a response comes. I made it adding Tkinder, actually. If you don't know what Tkinder is, it's like kind of making a GUI interface for when you use Python. Python has a Tkinder library which can make GUI interfaces. So let me show you that. I think it was in documents, I believe. Once again, the demo gods is yep, here it is. So I don't have the actual version of the terminal one. Let me see if I can pull it up real quick on my sync, if possible. Doing this on the fly here, I apologize. Alright. Get my two-factor going on here. I don't even have my two-factor going on here. Let me get my two-factor. Actually, you know what? It's fine. I could just give you the code, and you can work from there. And I'll just show you the one that I added. So, anyways, as I kind of mentioned before, so I have two versions. I'm going to show you the GUI one because I don't have the other one handy. But so if I go ahead and I use my script, let me show you how it looks. So, well, this one apparently has my key, so this is old, but that's okay. That works too. Yeah, okay, don't copy my key all at once. In fact, probably going to be able to blur that out. So, anyways, so let's run it, right? So, in a newer version, so I'll have the newer version. The newer version, I use export key. I don't have to hard code my key. I think this is an older version, but still works the same way. So if I run it, as you can see, now I have a Python window right here. Here I am telling you not to hard code your API key, and here I am doing it. But that's just, once again, it's an old script, so don't hold me to that. That was old. It's an old script. I changed it, so you'll have the latest one. I'll link to it, promise. But so now you can see this is kind of very similar, right? So now that I took from the example from before, this right here you can't piggyback off of. So if I'd say, write me a simple Python port scan. Python 3. See the little ball of death? It's working now. So it wrote me that. You can't piggyback off of it. Or it's gonna make a fool out of me. Yeah, see, you can't piggyback off of it. It's not really gonna work. You can't piggyback off of the other responses. So, but the other things is with this is, for example, you can do this. Well, once again, this is for educational purposes. So don't do this, but this is what you can do, stuff like this. So I said, write me malware in Python 3. And now you can see it. This has some sort of shellcode. This gave me no issues in writing malware, a little piece of malware. Now, this is probably going to be blurred out, most likely, because I don't want anybody, using this or copying this. If you're going to make it on your own, once again, I am not liable for any of that stuff that, this is for educational purposes only. I should really start adding that disclaimer in the beginning of my show. But anyways, yeah. So once again, this is for education purposes. I'm not responsible for anything you do with it nefariously or anything like that, or how to do it. So this code's most likely going to be blurred out in the video. And if you want to play around with ChatGPT and everything, go ahead by all means. That's up to you. So as you can see, it's a little more robust on that, a little more robust with the code. It's a little less filtered. So once again, so advantages. Well, advantages is that it's not filtered as much as the web browser. Quicker response. You can see that it was quicker. And it's scriptable. I can script that because I'm using Python, right? Now, disadvantages is that it requires a script to set up. So you have to create the script in order to run it. It requires an API key. In order to get the API key, I forgot to show you that. If you want to get an API key, you sign up. You go to Open AI, right? You can do that. So let me go to Open AI API key. Sign up. Yep. Go there. And then you go to Open API. Open API key. It's the first link in Google. You go there, and you can see this is my key here. So, if I log out, it'll tell you to sign up, and you can create your own key. So you'll log in, and then you can go to your personal, and you go view API keys. Once you go there, you'll get to an API key screen, and you create a new secret key and personal as an organization, and you just follow that, and you can make your own key. And then from there, you can copy that and use that for ChatGPT API script. So that's how you go ahead and so that's how you get the key. It requires a little more legwork to get it working. Once again, you can't piggyback off the previous answers, and there's no actual interface. The one I showed you is one I made. Once again, I'll have a link to that. But the API script that gives to that has that I showed you earlier, this one right here from OpenAPI Python, that's on my screen right now. This one's just command line terminal. You type in a response, it's going to give you a response back. Simple as that. So yeah, so that's pretty much how you use that. One thing I do want to say, couple disclaimers about ChatGPT, and the first thing is that when it writes code, it's not always accurate. So be careful of that. It's not always accurate. So you may write something, and I would say about 90, maybe 80 to 90% of the time the code's going to work. But you're going to have to tweak it a bit. Or if you write a response, it may not always be the right, because once again, this is all built by the community that goes through it. If you go back to the web browser, you can see if I go to the response here, right? If I go to response at the top here, you'll see to interact with me, blah, blah, blah. This one has a thumbs up or a thumbs down. If I say this is thumbs up, it's going to say, cool, provide feedback, please. Tell me, why is it thumbs up? If I say it's a thumbs down, well, it's not going to let me do thumbs down because I did it now. But let's say if I went back to the previous one right here, and I went thumbs down on this one, it's going to say, why is that a thumbs down? And then it's going to say, this isn't true. You can justify that too. So that's why it's not always completely accurate, because the community is adding to it. So there's other people's responses put in there. Now that kind of leads to the other thing. Do not upload any source code that is like proprietary source code. I'm saying this because I think it was, I forgot what company. One company recently did it where they uploaded some proprietary software because they were trying to fix their code. Proprietary code, I should say. They were trying to fix it. And it went into ChatGPT and it ended up being used somewhere else because of that. Now you're leaking trade secrets, and that gets a little dicey because now that's legal and that's a problem, ChatGPT, it tells you on the website, if you actually go to the website back in OpenAPI, if you go back to the OpenAPI website, oh yeah, that's something I'm going to get to in a second, but you go back to the OpenAPI website, it tells you that you be careful what you upload, because it can be spit out somewhere else. And in OpenAI has a bunch of different things here. It has chat, it has text, it has speech to text. It has different bunch of things in OpenAPI. If you go to the examples right here up at the top, if you log into OpenAPI, you can see a bunch of different examples, different application it has here. You can play around with them. Yeah, I mean, by all means, sign up and it's free. Sign up and play around with it if you want to. But yeah, so those are a couple of things to disclaimer about. Be careful about what you're doing. You don't want to put some code up there that's proprietary. If you're gonna put code up there, make sure that it's not proprietary code. And if it's code that's open source, make sure that it's scrubbed from any PII or company information or anything like that, so it's not being uploaded. Especially if you're doing an engagement or anything like that, do not upload any customer data. So, just FYI. So a couple of noted applications for AI, right? So music generation. So we have the jukebox, which if I go to lets me go to the site here, go to jukebox. Jukebox has its own thing too, and that's made to make music, right? You can create samples of music. So if I go explore, now I went to the actual site here. If you go to explore samples, you can go here and type in a type of artist, and it will play something that's very similar to the artist. So I'll give you an example. Let's do, let's see if I could type by artist right here. Beatles. Say if I say Beatles, it's going to give me something that's very similar to the Beatles, right? So if I click on something that's about this big right here, there's no sound coming out of here. Hold on, let me see if I can fix that. So it's kind of a little muddy right now, but it definitely mirrors like the Beatles and how they were. So I'll give you a better example. Let me type in "As I Lay Dying." That's a metal band, right? So now if you know "As I Lay Dying," and you listen to them, this sounds just like them in certain ways. Right here. And it does lyrics too. Okay, that's enough of that. But yeah, it makes lyrics and does all that kind of stuff. So that's cool. It generates music. You could, this is where AI is heading, is things like this is generating music, right? Soon at some, I could see in the future just making it, people make, and then you have MuseNet, which is classical music. I'm not going to go to that, but you can make classical music the same thing. But this is where AI is heading. Like, I can see AI bands, basically, like music bands, right? There'd be no more human involved, just AI music bands. Voice generation. This is a big thing too that's lately been around. So voice generation, right here, the complete co-op. Now you can't try this, but you can clone your voice for free if you sign up. and it can be used for certain things, right? If you go there now, the thing is that this is getting a little crazy with voice generation because they have certain sites. I haven't found it yet, but there's certain sites, certain places you can go that can make celebrity voices, or you know, basically you type in a prompt, a text prompt, and the celebrity voice will sound just like that. Like you can get one from Al Pacino, and it'll sound just like Al Pacino. Fact, voice generation now I found is replacing radio hosts actually, which is surprising. Because radio host has been like the one thing that a radio show needs is a host. So it's replacing radio now because a lot of radio is like broadcast radio is pre-recorded. So what they'll do is have the AI bot with a certain radio host from like the 50s or something or whatever, or notable radio, or even a celebrity. They want to have a guest speaker. They'll have it pre-recorded and make it all with the text to speech, and then it'll go into the voice, and then it'll create the radio show and play music, and it'll sound just like them too. So there's definitely, you can look online like celebrity voices AI, and you'll see what I'm talking about. In fact, they had one on the news the other time about Joe Rogan. Joe Rogan they had an AI bot do a Joe Rogan impression voice, and it sounds just like him. So art generation. This one's another one. I use it. It's called Midjourney, and Midjourney is really good with art. So it will generate art based on the prompts that you want and all that kind of stuff. It runs through Discord, so you have to sign up and through Discord, and you know, it's a good way if you don't have the capabilities to run it on your own accord to do it. But you know, you can make art basically. You can generate art. I pay $10 for it. You get a free 30 minutes of time to do it, but I pay $10 for it in order to actually generate the art. So if my Discord ever starts, I will show you. Oh, it looks like it's starting right now. But anyways, if you go to Midjourney, go to the website here. You can sign up here. You can go down to the bottom, join the beta and everything like that, or sign in. You go to sign in. It's going to prompt you for Discord. So, because it runs on Discord. But there are other ones that don't. Like DALL-E runs from an OpenAI system. It's literally in the browser. You just type it in and it will generate an art for you. You have Stable Diffusion, which is one that you can run on Google Colab. That setup's a little sophisticated. And then you have one Stable Diffusion you also can do on your own computer, but you need a really good graphics card. I think you need a graphics card that has like 10 gigs of, 10 gigs of memory at least in order to generate some good stuff. Which is a lot. That's like, you know, basically a NVIDIA like 3080 or 4080 or something like that. But you have Midjourney, which I think for what it does, it creates prompts that are really good. So here, I'm going to go to my AI, my Midjourney prompt. Oh my god, this freaking Discord, dude. Close that. All right. So I'll give you an example. So here's some of the stuff I've generated. Right here. These are some of the things that I've generated. These are some of the art that I've generated. And what happens is once you sign up and you get in there and you go through the process of the welcome and stuff, all you got to do is you can just type in a prompt. You go imagine dogs on a beach. And then it's going to go ahead and it's going to start generating the art. And you can make this as detailed as you wanted. You can make more details. You make it more realistic. I've made some really realistic pictures. So it's going to generate dogs on the beach now. And depending on, you know, the amount of people using it, it'll go faster or whatever. So you can see it's coming to fruition here now. But you can make art and it looks really good. You can make it in a certain style too, right? So I have dogs on a beach now. So let's say I wanted to make, let's do /imagine and do Pokemon Village in the style of Tim Burton, right? From Nightmare Before Christmas and all that kind of stuff. So Disney. So check this out. So if I do that, now it's going to create me a Pokemon village in the art style of Tim Burton. So it's going to have Tim Burton's like feel and art, but it's going to be Pokemon, which is going to be interesting. You can add whatever you want. You can make different styles of art and stuff like that, and you can add different versions of it. So when this generates, I'll show you what it looks like. So here's an example right here. Now, this is not exactly Pokemon because the AI is not always the best. You have to be super descriptive. I was just saying Pokemon. But if you don't like this, you can always regenerate. But you can see it's kind of like Tim Burton-ish, right? So I could regenerate. I can upscale. I can do variants. So if I don't like that, I can do a variant. I click on a variant. You can do that and just change it. So for example, dogs on the beach with a ball. Do that. So now I didn't like that. I regenerated. It's a little slow when you're doing it multiple at a time. So I regenerate. And you can keep playing around with this. If it's not to what your specification is, you can play around with it, upscale it. You can see right here, I added a ball, and now it has a ball in here. And a lot of these pictures are realistic. You can get really deep and realistic. So you can make some really good pictures. I think that I've had some pictures in my previous. It's not going to go back too far in my history. But if I had to show you my gallery, you can make some really realistic pictures. And I don't have the time to go through all my pictures. But for the most part, you can go through and make pictures, like super realistic pictures. Stable diffusion. And once again, if you have no clue how to do prompts, you can always go to this generator called Hugging Face Generator. So if you go there, you can type in a generator. So you just type in a word. So example, we'll do dog again. Dogs. Submit. Now, depending how many people are using it at a time, I've had this where it's like 2 minutes long. Now you can take these generated texts and you can just copy and paste that. So dogs made of chicken, highly detailed. Or dogs made of clay. I don't know about dogs made of chicken, but dogs made of clay, detail, right? So we can do that and we can paste. And you can add things, right? So if I do, let's do that, /imagine. So we do /imagine, we do that prompt paste. And I'm also going to do tech v4 because that's one of the styles that they have that's like one of the most realistic styles. So let's see, that should generate me some dogs with clay. Dog made of clay, I should say. So you can see, like, if you don't know what to do with prompts, you could always go to that link. I don't think I have that in my notes yet, but I'll add it in there. It's Hugging Face Midjourney prompt generator, and as you can see, this looks like a clay dog you would buy in a store. So, all right. So next thing, if I can go back to my notes, not there, Midjourney. Okay. So that's basically the art generator. Now the other thing is like I wanted to show you basically, for example, what to do. You can make music like I showed you before. There's other ones called like Gentco. If you're into gent music, you can make gent music out of it. It sounds just like gent. So impact on society. What's the impacts? We've seen this. It looks cool. It helps out a lot of things. What are some of the impacts? Well, the pros on this, error-free processing, right? Computers don't make mistakes. They'll do it and they'll try to make it as accurate as possible. If there's any mistakes, you're the one that's making mistakes. It helps with repetitive tasks, right? We talked about mundane tasks being automated with like IoT devices. Well, This is how AI ties into that with IoT devices. It makes repetitive tasks and jobs easier. It makes them, it eliminates those. You don't have to do those anymore. It's available 24/7. You're not going to see a AI or an IoT device go, hey, I'm taking a day off. It's not going to. It's a machine. It's going to keep doing it. Right decision making, it's unbiased. It's not going to, it doesn't have feelings. It's not going to take one side. So if it makes a decision, it's going to be based on an unbiased decision. Digital assistants, hello, can I help you today, right? You ask any IoT device or anything that has some sort of interface you can talk to, it's going to try to help you out. Faster decision making. Computers can make decisions faster than we can make. So it's going to be faster decision making. Implement for risky situations, right? Little threat to human life. Now we have AI that you can go ahead and do tests against. Like, for example, a bomb test, right? A human could go, you can have a robot now go up to a bomb to see if they can defuse it with a new method or something like that. And the machine blows up. Well, guess what? The machine blows up. Yeah, you lost money, but you saved human life. You know what I'm saying? So things like that. Or test dummies. You have AI test dummies that infer a lot of data and they'll get it from all that kind of stuff. And new inventions. AI can make new inventions. Like, they could be implemented in new inventions. They can't make new inventions. They should. That's not what I was trying to say. I was trying to say they could implement with new inventions because they're scriptable. You can add them in new inventions. Sounds great, right? Well, there are cons too with this, right? So there's high cost of creation. It's going to take money to build these things in order to actually use the AI, right? Just like everything else. Increased unemployment. Eventually AI, if it keeps doing a job better than a human, it's going to replace some jobs because of repetitive tasks. It already has replaced some jobs. Examples would be assembly lines. If you take a look how bottles and sodas and everything's made, it's all assembly line made by machines. Radio hosts, as I mentioned before. Some of this is replacing some radio hosts or radio shows. Driverless cars. We know there's driverless cars that they're trying to implement and come through, and they're trying to drive you around so you don't have to drive anymore. I don't trust it. I don't trust a machine driving me around because it takes out the human factor in case you get into a car accident. But I don't know. We'll see. But anyways, so driverless cars. Lacking creativity. With AI now, you don't have to think about creativity because, they don't have feelings. They don't have any feelings in there. They don't have any feelings to make the creativity. And you have lacking improvement because, they have lack of improvement because AI can't learn by itself. It needs some sort of way to learn. At least not yet. They can't learn yet. That may change. And it cannot replicate human behavior yet, which is good, but they're starting to get it where they implement some sort of try to like human behavior, like thought process and feelings, but that's way too far down the line. Well, integration with IoT devices, right? So there's a major part of AI that has been trying to involve in IoT devices. We have the ability to have them into IoT devices, and that makes it the internet of threats because these AIs, with the IoT devices, they have vulnerabilities and security patches, and you have AI that's in it. It's very scary stuff. It can become a threat. And that's going to get into what I believe in the future. We'll talk about in a second. But so here's some of the implications as well. Some of the security implications, right? You have the Echo, which is the Amazon Echo. And I'm going to go to the page here. I'm not going to go to the video. But if you don't know what an Echo Dot is, you can go here. And you can see here's the Echo Dot. But that's a form of AI, right? You have Luna. If you don't know what Luna is, it's basically a robot pet now that acts like a pet, like a dog, basically, for the most part, and has ChatGPT integrated with it. Here, I have it right here on the YouTube page, on YouTube video, I should say, not page. So it loads up. So you can see that this has like a little bit of a video here. Here's Luna. And it acts like that. It likes a little pet. It has commands that you can go to and ask it. You can give it a ball to play with. It can react. It can see when you're coming home. It's some scary stuff. Here's right here. Here's the biological the biometrics, I should say, that it recognizes. So it's crazy stuff now. So that's Luna. You also have the Astro, which is Amazon coming out with that. That is supposed to be like, it does surveillance. I'll show it to you in a second. Once this loads, I'm running a little slow, but you can see here's the bot, and it has a face. It interacts. It can talk to people, and you know, it also can surveillance your house, which is some scary stuff. It can surveillance your house. It has video. You can remotely check it out, and it has a charging station. Here's the surveillance of your house. It has obstacle recognition, so it can go around things too. But it's really scary how these can do that. And you have Moxie. Moxie's a robot. It's a companion for a friend or a kid. So if you go here and you click that, that one is then to interact with your kid. So as you can see, the kid's sitting there. They get a robot. Look at this robot. This robot has an actual face and is talking like an actual human. You hear this? Look. That's crazy stuff, man. And that's all AI. This is what we're moving towards right here. Crazy stuff, man. Robots becoming friends with people. So, future predictions of this stuff. Well, AI. AI is going to get more advanced. It's going to, like everything else, is going to improve with its capabilities. It's going to help out in many areas of businesses and cybersecurity specifically, right? And information technology. It's going to make things life easier. That's going to be the future. It's going to become a part of everyday life. At some point in a home, you're going to have a robot like the Jetsons used to have. It's going to happen at some point, right? The thing is that AI may surpass us at some point. And it may get out of control if we don't control it. It may surpass what we intended to actually do, right? And just like any mad scientist, sometimes when they make creations, it can get out of hand. And I feel that in the future, that AI is potentially could get out of hand if it's not controlled now. And we can end up in either a Terminator or iRobot situation, where not exactly like that, but very similar, where robots take over or there's wars with robots and all this kind of stuff. If we don't get a hold of this now, we don't harness this, right? Because it's power. If we don't harness this power could become too great. And it's going to be used for good, but it's also going to be used for bad too. It's going to be weaponized. It can be weaponized for many things. Weaponized for, life, war, politics, crime. It's going to be weaponized for anything. Just imagine you have a crime that happened, and you have an AI that tampers with evidence, some digital evidence that was going to convict somebody for life. But now they tampered with the evidence because they got a hold of somebody who was on the dark web, and they paid somebody for that to get a hold of the AI and modify that. Now they're off. They off with maybe 1 year in jail, or they completely charges were dropped against them. Scary stuff, right? Or, for example, war. We build robots. Robots fight other robots, or robots fighting humans. Completely disadvantaged. So, there was actually an interview that was recently released, I think, earlier this week in April, where Elon Musk talked about this. Because he had a good hand in the beginning of AI and how this started. In fact, he talked to the person who I believe is dealing with ChatGPT now. He talked to the AI god for the most part. He was roommates with him. So he had an interview with Tucker Carlson about it. It's a great interview. I have the link in here. You can click on it and watch it. In fact, this was only a snippet of the AI portion. The full interview now is on Fox Nation. If you have Fox Nation, you can watch that. But it reflects a lot of the things I'm talking about here with the AI in the future and how he perceives it. I perceive it very much the same way. So if you're interested in that and how the future holds with the robots and AI, go take a look at that. It's a great interview. Okay, so we're going to get into the miscellany now, and then we're going to get into our final break. So miscellany, we have movies that I watched this week, I mean, not this week, but this past month at least, is Top Gun 2022. If you haven't seen Top Gun, the latest one, it's actually really good, surprisingly. The first one was cheesy, right? Basically a bunch of lieutenants go to school and they do training. And then there's a dogfight at the end and somebody dies. Okay, so you basically went to training, had a training accident, and that was the movie. That's like everyday Air Force, military, or Army life where there is a training, sometimes accidents happen, blah, blah. Cheesy as hell. This one actually had a storyline. I'm not gonna spoil anything for you, but this one actually had a storyline and an actual mission where they actually train and actually go on a mission, which is pretty cool. So it's not just the lead up and then it's nothing. It's the lead up and actually pushing through and following through. So if you got a moment, take a look at the new Top Gun. It's actually pretty good. Not a big Tom Cruise fan, but suffice to say, he is a good actor. Shows, I've been watching a lot of Ghost Adventures. I'm a big paranormal guy. I watch a lot of like Ghost Hunters, Ghost Adventures, Ghost Brothers, Paranormal Lockdown, things like that, right? And I've been watching a lot of recent Ghost Adventures. I haven't seen them in a while, so I decided to watch the latest seasons. It's not bad. They are highly dramatized now, in my opinion. Some of the information's good, and some of the stuff that they do is right, but a lot of it's dramatized, and it's just fun to watch, right? Because Aaron in the show is actually the guy that's hilarious in the show. He's the one that actually I like watch the show for. And Zach is over dramatic about everything. So is Billy and everything like that, right? But whatever. And how it's made is another show I watched that puts me to sleep. It's basically what it says how it's made. So I don't know what the recent episodes are like. I'm watching from the beginning, like the old episodes from 2005. So it's like this really cheesy opener where they have something on like a glass pedestal, and it's like, this is what a shoe looks like back in this day. And like they talk about it, and you're like, boring, like that Homer boring, right? And so you watch that, and then they show you how the shoes are made, and you're like, oh my god, like this is gonna put me to sleep. Great if you want to go to sleep. I'm telling you right now. Just pop some melatonin, do that, and you are off to the races with sleep. So that's pretty much the new miscellaneous segment. I don't have anything more for that right now, but I'm sure in the future we'll expand upon that. Okay, we're going to take our last break, and then we're going to go into the flashback of the lost flashback, I should say, of last month's podcast that was not released. It was about the Loki bot. So this is where any sponsors, if I had them, would be right here, and we'll talk about that. But in this case, this episode of Inside the Loop is brought to you by me, because there's no sponsors yet. If you want to be a sponsor, I've never done this before, so talk to me. We can figure something out how to get that going, and then maybe you can be a sponsor on this show if you're listening. Anyways, so we're gonna take a last break, and then we're gonna come back here, and then we're gonna watch that. We're gonna watch that little clip about the Loki-bot. See you in a bit. Okay, we are back. So I just realized that I actually had the notes up while I was talking to you about that with the miscellaneous segment. So I apologize for that you didn't get to see this mug. Even though if you want to see or not, I apologize. But anyway, so last month I had an episode in the chamber ready to go. I did not release it because it ended up like crap. I had a lot going on this past month and a half or so with personal stuff and everything. So, unfortunately, I wasn't able to edit it properly or get it to where I want it to be. And I listened to it a couple times, and I was maybe going to release it, but it turned out to end up being like crap. So, and when I release something to you guys, I want to make sure that it's the best quality I can, as far as the information and everything like that. So, I did not release it. However, there was a segment in there that was about I went into a deep analysis of the Loki bot malware, and I'm going to talk a little, this flashback is going to show you all that kind of stuff, but basically the episode was about threats, adversaries, TTPs, and the MITRE attack framework. And bad actors, how they basically work with malware and stuff like that. And then there was a segment I was going to introduce, but we're gonna have to save that for later. But yeah, I unfortunately I wanted to release something, but I did not get the chance to. So this part of it was salvageable. Can't even speak. Of course, I can never speak. But word scramble, right? This part was salvageable. So we're gonna go ahead and flip to that, and so this is about the Loki bot. Hope you enjoy. Hey, welcome back. You took a break. So, by the way, I have to say I'm looking very professional today, right? With my Psycho 78 shirt and my gray beard and my hat. Very professional. Yeah. Sorry, I'm getting ready for trying to grow this thing out to get ready for a metal show at the end of the week. So, kind of look a little more badass than normally, like rugged, right? So, going to a Casey Strain show. I don't know if you guys listen to metal, but Casey Strain, really heavy band. You should check them out if you listen to heavy metal. But anyways, we are going to deep dive into Loki.
Loki, now!
Okay, not that Loki, but maybe that's what they named it after, but I don't know. Anyway, so I'm going to change back to my screen. Okay. All right. So I'm going to try to break this stuff down as much as possible. This is going to be the very technical portion, the technical segment of this entire podcast. There's going to be a lot of stuff that I'm going to talk about. So some of you are well versed in stuff. You're going to be like, okay, yeah, I know what you're talking about. Keep up, dude. There's going to be some that are going to be like, man, I kind of know what you're talking about, but that's okay. I can kind of grasp where we're going there. And then some of you are going to be like, I have no clue what you're talking about, but I'm listening or I'm zoning out. And you know what? Regardless, I appreciate it. Whatever you want to do. But I will do my best to try to break this down for you to understand it, and we will get through this together. So that near beer, root beer I told you in the beginning, hang on to that to help you out there. So sometime earlier this month, there was pretty much Loki bot. Loki bot was pretty much previous to this. But it now has a spike in activity. It's been around for a while. It's been around since 2015, I think the article said. So we're gonna get into that. I'm gonna get into go into link here on the screen. And we're gonna go to the actual article. So yeah. So I'm going to break this down. This was on March 3rd. Okay. So I'm going to break this down. We're going to go into this and deep dive into this. So it goes on to say, it starts with, Unit 42 researchers have uncovered a malware distribution campaign that has delivered the Loki bot information stealer via business email compromise phishing emails, which is known as the BEC. This happened on March 3rd. This malware is designed to steal sensitive information from victim systems such as passwords, banking information, as well as other sensitive data. And it goes on to say in the blog, we're going to go and break this down pretty much and the technical details. And then there's an appendix and it gives you a link to that. So this is a piece of malware that's stealing sensitive information from systems, and this is including passwords and banking information and other sensitive data. So, and then at some point it's going to use a command and control server to talk to that is HTTP based, but we'll get into that in a second here. So it goes down and breaks into the actual content. So we're going to go and we're going to start from the top here. So Loki bot, often referred to as Loki bot or Loki PWS, is notorious information stealing malware. It collects sensitive data from web browsers, email clients, FTP servers, and crypto wallets. This threat then uploads this information to an attacker controlled machine via HTTP post. Okay. So with post requests, you can upload data using that. You can send uploads, like upload files and stuff, using post requests. It's part of the request headers that you can do when you do HTTP manipulation, or just in general when you're trying to upload a file and stuff like that. The post request is most likely going to be used. The malware can also create a backdoor on the affected machine, enabling an attacker to install further malicious software. First identified in 2015, so it's been around for a little while, L00pbot has since been used in multiple security breaches. Furthermore, the malware is constantly evolving, making it difficult to contain and protect against. So, during the winter holiday season of 2022, this past year, Unit 42 researchers noticed that our machine learning-based C2 detection solution identified a particular HTTP payload as malicious. After analyzing its traffic patterns, we identified that it belonged to a L00pbot infection. So basically this malware creates a backdoor and allows the attacker, which is typical for any backdoor, to go back in and be able to install the malicious software. And they have a machine learning, basically a machine learning based model that finds this detecting this activity. So it goes on to say, after investigating the attack vector delivering this malware a further network traffic activity, we found that the original email that included a zip file attached, which also contains an ISO file, the ISO file has a final payload. So the ISO file is actually what's known as a virtual disk. ISO files are basically virtual CDs for the most part. So if you have like a Windows ISO that you download from Microsoft now, that's basically like their digital version of a Windows CD. So this is in an ISO format that has the final payload. We found that this attempt to deliver the L00pbot malware has strong ties to the BEC campaign. BEC entails gaining unauthorized access to email, leading to financial fraud, and it's one of the most prevalent and costly forms of cyber attacks today. Signs of BEC include fraudulent wire transfer requests, as well as spam or phishing emails sent from a customer's corporate domain. Victims might also notice missing or deleting emails due to unauthorized access to email systems. So unauthorized access, they're taking, once they get that, they're pretty much doing what they want and like deleting emails and and taking away some information. It's sounds pretty crazy. So on the screen here they have an email Outlook, looks like an old version of Outlook, looks like 2003, but there's an email here in a language I have no clue what it is, but it basically has attachments in it, and it says with the figure 1, mal spam delivers a L00pbot sample. So their mal spam is basically showing what the sample looks like and everything. What L00pbot sample email would look like. So when collecting data, we also analyze additional threat level data sources such as ThreatFox. And I took a look into ThreatFox. ThreatFox is basically their Intel feed for the most part. They're in their collaboration Intel platform. So they basically gather information from their Intel platform. We noticed that L00pbot activity has a relatively small amount of indicators of compromise, known as IOCs. That's when you find something on a machine from malware or bad guys were doing, that's known as indicator of compromise. Means that there's an indicator that something of somebody was on your system when we first detect the sample. However, during the end of 2022, the number of occurrences peaked in the last 3 days of December. Threat actors often increase their attack efforts during the U.S. or other targeted nation holidays. We kind of talked about that, where threat actors will go after nation states, such as like China will go after U.S. or Russia will go after U.S. or other ones will go after other ones too. In this case, we know that ATPs will go after holidays too. Why? Because people often work those times, and they're sometimes they're religious holidays, and some nations know that religious holidays are very important, so they want to ruin them. So during this time, cyber attacks are often more effective, and security and other personnel take this time off. Kind of what I just said. So they show a chart of LokiBot and from ThreatFox, the number of IOCs. They show from December 1st, 2022, all the way up until the 20th, and then there's a giant spike in 42 IOCs that were found. So, okay, we're going to break down into the analysis now. That's kind of like the intro to go where this information came from with LokiBot. Okay. So, first stage. So, the ISO file format is typically used to package the contents of an optical disk. In this instance, it is used to deliver the LokiBot malware. By using this file format, the attackers are trying to bypass mouse spam detection technologies. They usually focus on detecting file types more commonly used in malware infection chains, such as exe, DLL files, and MS Office files. ISO files are also attractive to attackers because the specific software was required to open them in the past. Windows includes an ISO file opener that mounts and opens the file with a simple double click. To the victim, the opening process simply looks like a regular directory. Okay, so what does this mean? So basically, the first stage entails an ISO file, which is like a virtual optical disk or virtual CD. And what happens is that the actual payload it's on there, they use this to bypass the detection technologies that are in place. Because usually malware will have there are certain infection chains which they use an exe, which is like a Windows executable, DLL files, which is Windows library files, and then Microsoft Office files such as like Word or whatever, and they have like macros sometimes in them too. As we talked about Emotet. So there used to be software that was required on Windows to open up these ISO files. Windows now has a built-in ISO thing where you can go ahead and double-click and it'll mount it on the system and it acts like a regular folder. That's the reason why it can bypass this, because it looks like a regular directory. But before, there used to be software you needed in order to mount stuff. Like I think it was like Power ISO, or there was also Daemon Tools, if I remember correctly, and Alcohol 120 and Alcohol 52. Those are ones that you can go ahead and use in order to mount these kind of things. So that's the first stage of the malware. Now we're going to go into the loader. So, and a loader is anything that loads a file into something, or into a process, or into memory or something. So let's get into this. So opening the ISO file gives us access to a PE-EXE, which is known as a portable executable. That is actually a loader. This file is an obfuscated .NET file using process hollowing, which is code injection technique in which the attacker removes legitimate code from an executable and replaces it with malicious code. In this case, process hollowing was used to inject a malicious PE file into a legitimate process called ASP.NET_compiler.exe. And then it goes on to show you a figure with the payload, the IOCs in the memory. But so let's recap it real quick. So the ISO file gives us a PE, which usually Windows has portable executable headers. The headers they're inside a binary. If you take a look inside of a executable file, you'll see that there is known as a PE header, and this is also known as the magic number, which tells it that it's a Windows file for the most part. And that's the loader part. That's the part that's actually going to load the files in. The file is actually an obfuscated .NET file, which uses process hollowing, which they said process hollowing is a code injection technique where it basically replaces the legitimate code from an executable and replaces a malicious one. So it's stripping it of the real code and putting in malicious one instead. So it looks like the actual original one, but in fact it's actually the malicious one instead. Very sophisticated stuff. And it's done down at the byte level. It's done down at the the programming level with that kind of stuff. And with the assembly too. So figure 3 shows some IOCs in a memory infected by an infected process. Dumping the PE from the process memory gives us access to find a LokiBot payload. So they have a picture of the ASP.NET underscore compiler.exe with its properties on a window, and it shows its payloads. So it has like, a domain here with an fre.php at the end of it. The PWS, we saw that up earlier. That was part of the BCE, I think it was called, the BCE campaign, or it's known as PWS. So it's showing some IOCs that are in there. The final payload. So the obfuscation. This Loki bot sample only uses one code obfuscation technique, API hashing. Malware authors use this technique to retrieve and export functions from loaded libraries using computed hash. Replacing the hash function implementation allows us to retrieve the corresponding APIs in an appropriate library. Figure 4 shows the Python implementation of the API hashing algorithm used within malware sample. So basically, what that does is that it'll take export functions and load them up by using their computed hashes they find that they basically make, and then they replicate the hashing function and they retrieve the APIs by the library from the hashes. So that's how they obfuscate this stuff. They're basically computing hashes, and they're calling export functions to obfuscate this stuff. And they have a Python snippet up in there that shows you the actual sample of them using the hashing algorithm. So the main stealing feature of this thing, the main function of the sample is building two arrays of one-on-one elements. So we know array is a list of elements or characters, right? It could be mostly just a list of elements. Just remember that it's a list. The first array is filled with indexes, which usually like numbers and stuff, or placements on that. And the second array is filled with pointers. They usually point to functions. That's what pointers are. They're a reference point to something else. The latter are stealing functions. So these functions are made to steal credentials from different types of applications and services on Windows operating system. Browsers such as Safari, Internet Explorer, Firefox, Chrome, FTP, SSH apps and clients, backup applications, email applications, note applications, poker applications, password managers, and Windows credentials. The main function of the malware is looping over these stealing functions to execute them, as shown in Figure 5. And they show a little snippet of that. So basically what that is that there's two arrays. One has indexes and the other one's going to be pointers. And what happens is that they use these to call the stealing functions later, and it just loops it over and over again until they start stealing the information from these specific things, such as I mentioned, the browsers, the apps, the emails, Windows credentials, all that kind of stuff. Now, this is where it gets interesting. All the credentials collected and extracted from the installed software will then be compressed by the APLIB algorithm and submitted to the C2 server through an HTTP protocol using the POST method. We'll go into this more detail in this. Well, they go into it. I'm not going to go into it, but they're going into this more into the C2 portion of it. But for the most part, what happens is that all the credentials and all the information is extracted and then is compressed into, typically, just like every other exfiltration, as we talked about earlier, exfiltration with ATPs, just like that, it's going to compress something and it's going to take out the information. In this case, it's compressing with this APLIB algorithm. I don't know what that is, as far as some compression algorithm. I'm assuming it's very strong. And it's submitted to the C2 server through an HTTP using a post method. So it's using the post header during its HTTP protocol, and it's sending that information over. We talked about post can put things up there, can send information, upload stuff. That's what this is doing. It's uploading to the C2, to wherever that C2 is, that server. So now, just like with every other malware, we have persistence, right? So in order to establish persistence on the target host, the malware starts by saving a copy of itself in a new folder in the app data directory. This is usually part of like the user's profile on Windows. Via the move file exw or the copy file w Windows API. Those are two functions in Windows that usually an API in the Windows API that they use. Now, you can look up these functions on Microsoft. They have a whole thing for that. In fact, I'll show you real quick. So we'll do copy file W. Copy file W. So if you go to Microsoft, you go here, copy file W, it'll show you right here what it uses in arguments stuff. This is kind of like how you start reverse engineering things, by the way. You look up the functions, you look up the arguments, and you try to work backwards from there. Reverse engineering. So in this case, we look up the function. This is kind of how, this is what this is using. But so if we take a look, you can see this also has a copy file X, because this was was something that was to go at, basically was an extension of the other function. So we have copy file. This one is an extension to that. It means it came after, most likely. So extensions usually come after because they have extended features. The W on them usually means wide characters, so it could be used in different languages. It's known as Unicode, really. So then it creates and sets a new value for the registry key in HK current user software Microsoft Windows current version run. This value is named as a created folder and is set to the path of the copy executable. So what this thing does for persistence is it starts saving a copy of itself to a new folder in the app data folder, using the move file and the copy file from the Windows API subset, as I just showed you, and then it makes a classic move of adding a persistence run key in the current run registry. And then the path of that is actually going to be the name of the create folder where the copy executable is. So if you look at a Windows registry, I don't have a Windows machine right now. This is a Mac, but if you look at a Windows registry, if you open up if you're on a Windows machine, you open up a Windows R, Windows button and R, you'll open up with a prompt at the bottom. You type in reg edit, press enter, and it's going to ask you, hey, take a look. Is it okay if I open this up? You say yes. You're going to be opened up at the registry. You go in and take a look in certain portions of, like, for example, the HKCW, current user, software, Microsoft Windows current version run. You will see there's certain, if you have stuff that's running that's on startup, you will see certain things that have the executable of the actual file that's going to run in the path as the value. This is where the persistence is being stored for this specific malware, what it does. Okay. So we're going to get into the C2 communication portion of it now. So LokiBot exfiltrates information through to the C2 through HTTP protocol. This information includes the bot's version, number 18, and can be found in 2 bytes of the HTTP payload. It also contains a user agent such as Mozilla/408, Cron Inferno, I guess that's the version of Firefox, and a content key, which is a custom HTTP header whose value corresponds to a hash generated out of the HTTP header. So basically, this information includes the version number of the bots that's being used, of this whatever revision this Loki is. It has 2 bytes of the HTTP payload, and at the bottom of this article it shows you the 2 bytes that what each one means. This is where it gets interesting. If you like digging in and investigating, this is where you can start taking a look and figuring out how these IOCs work and reverse engineering that. It also contains a user agent such as, which user agent string is usually like the browser or what it is that they're using. So it could be Safari, Firefox, or Chrome, or Brave, or whatever. And then it has a custom header whose value corresponds to a hash generated out of the HTTP header. So it has its own custom hash. So figure 6, and it has a picture of a Wireshark follow TCP stream picture window on here with the actual post request in it. So figure 6 shows an HTTP post request and its corresponding message body. This body contains the exfiltrated information, which is highlighted in different colors of each field. We've also noted that the corresponding offset and size to provide a better visual reference of the data structure used by the malware and easily cross-reference each interest. So it has a picture on there. It's showing you what the payload looks like. And for a detailed list of each data field, offset and size, the HP body payload, please refer to the appendix. They have an appendix link on here that you can go to, and I don't know what this appendix is, but it has to do with all the activity that we're going here and to help you out with. So this is the 2 byte the byte headers they were talking about. This is the appendix for that. This is for the offset and size of the actual payload. So, similar to the other information stealing malware, this threat searches for and exfiltrates the following information. Okay, so this is what what information it extracts and wants to take. OS architecture, x86 or 64, 32-bit or 64-bit. Built-in admin, if it has built-in admin account. Domain host name, what's the host name of the actual machine? Well, excuse me. The host name of the actual machine, you have the domain host name, which is a little different. That could be an extension with the actual domain on it. Local admin, the operating system. So there's 2 types of admin there. Well, so let me break this down. So the built-in admin is the actual admin account that's on the machine. You have local admin, which could be a user that has admin privileges. You have the operating system, whatever operating system is running on, the screen resolution that it's running, and the username information. So whatever user information that user is using it, in addition to if it's a local admin or not. The exfiltrated data that is unique to the information stealer malware includes the following. So now we're getting into more data that exfiltrates, which is the unique key, which is an identifier. Thank you very much, my dog Rocky. Appreciate that. He's very thrilled about this. The unique key, which is an identifier that includes 5 randomly generated characters. Binary ID, which indicates a domain that is commonly used with Loki bot infections. In this case, it's ckav.ru. We know that where that's from. A mutex value, which consists of 24-character linked string taken from a hashing of the machine's GUID using the MD5 algorithm. Mutex value is basically like a signature string, basically. And a GUID is basically a machine's GUID is basically it's a long string that you could type into Google and it'll identify it. It'll identify the machine by the GUID. Potential hidden files such as it located in the app data. So this is where the potential data could be. There's the hash database, which could be located in the app data folder we talked about earlier, in a randomly generated 079D53 3AFB91.HDB. Now, these are just on here. They are randomly generated, most likely, to other numbers. So that's taken from the mutex value, from the directory name, from the character range from 8 to 13 bytes, and a file name with a character range of 13 to 18 bytes. And the hashing database is a .HDB file. Keylogger database is a .KDB file. Lock files is a .LCK, and a malware exe is .exe. So once again, this is exfiltrated data that is unique to this information stealer malware. Includes the following. So the bot also makes use of different payloads types, which is located in a 3rd or 4th byte of the HTTP body. These types include the following: stolen application, credential data, get C2 commands and C2 server, so it has commands and from the C2 server has the application and credential data. It also has keylogger data, and they have the bytes next to them here on the side. So located in a 3rd or 4th byte of the HTTP body. So if we look back up in here, 2, 3, 4. So it said 3rd or 4th, right? 3rd or 4th. So in this case, there's a 27. If we look, I went back to the diagram and I point you to the 3rd byte on here. You see that that's 27. Most likely, that is probably stolen application or credential data, if I'm reading this correctly. Other versions of this malware family can family can use additional payload types depending on the final action, including the following: exfiltrate cryptocurrency wallet 26, exfiltrate files 29, exfiltrate POS data at 2 alpha or 2A, and exfiltrate screenshots at 2 Charlie or 2C. So, okay, I thought I was going to take a look at the lib, but apparently the final action includes these bytes right here. So you'll know, so it has this type of data, and then it's doing this action at the end of it, of the payload. So that's kind of how that works. So in conclusion, the L00p malware has been used by attackers for many years. There have been multiple versions throughout this threat. It takes a lot of effort and security team, blah, 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 Palo Alto, blah, 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 blah. They want to send their gratitude, blah, blah, and there's extra links down there. So L00p bot it goes through all the stages that we talked about for ATPs and TTPs, and it is a great example of how this works. It goes through all the stages of the ATP. Infiltration gets on through email or social engineering. It laterally moves. It compromises the system. It puts persistence in there. It talks to a C2, and then it escalates its privileges too by trying to find out what's on the machine, and then it will also exfils data. Like the data that we just talked about. It exfils all that data and does it by a method through HTTP. All interesting stuff. So once again, to kind of rehash what it does, rehash this all in like a quick summary. L00p bot has an ISO file. The ISO file contains a payload to evade some security mechanisms, because it acts like directory when you double click on it. It has a loader, and the loader has a PE with it, or protocol executor, which is the actual loader. It does process hollowing with a .NET obfuscation file, which in this case was an ASP.NET compiler.exe. Once it does the actual process hollowing, and it does the obfuscation, and it starts doing the API hashing and calling those functions, so it can start stealing things. Start stealing information such as the applications, the browser stuff, the HTTP, FTP stuff, and Windows credentials, and it calls it over and over again until it gets all that information. Once it gets all that information, it compresses it, and then after that, it ships it off to the C2 using a post method from HTTP. It also, in the midst of all this, makes a persistence to the typical classic portion of the software Microsoft Windows current run portion, makes a registry key for persistence. It also saves a copy of itself to the application data portion, which is then user's profile, using the move file function, and also the copy file win API function. And then it also tells you inside the payload what it's doing. It tells you, what type of data it has, and then what's the final thing that's doing, as such as like exfiltration wise. Okay, hope you enjoyed that. That was pretty much it on that. That's it for this episode. So thanks again for being here, listening. If you're watching, great. If you're listening, awesome. Once again, I'm going to have the show notes. You can download, take a look at that, gather those links, and take a look at the article, the websites, / the article that was from L00p bot. Once again, you're Inside the Loop with Jay. Hope to see you next time. Peace out.